We have Mr. Dev Singh here. He's the VP and GM of Building, Enterprise and Industrial Automation and Digital Transformation at QUALCOMM. He'll be speaking about evolving the robotics industry and using ROS along with.
Good afternoon, everybody. My friend just told me that I should have shaved because it would match the picture that I had. I'm like, yeah, maybe with the young cloud I should look young, but this works in the corporate world. So again, as introduced, I'm Dev Singh. I lead a couple of IoT segments at QUALCOMM, one of which is automation, and robotics is part of that, robotics and drone. So we'll talk about that, and I know you guys are all researchers and doing a lot of work on ROS, but my perspective I want to share today is from the commercialization angle and how things are in terms of making money. I'm a business guy here. So those of you who know QUALCOMM or who don't know QUALCOMM, just a brief thing. QUALCOMM stands for Quality Communications. We started off as a communication leader. We have transformed and digitized mobile communication. That was how we started. But then we have also not only the modem aspect of things, we have a great application processor. So we've been redefining how computing is done, not only on smartphones, but on compute, laptops and others. And now as we speak, we are in middle of transforming industries, be it automotive, be it industrial, be it factories. QUALCOMM technology from communications to application processors are being used to make things smarter and connect everything. So I'll talk about that. So at QUALCOMM, what we have been doing, we work on all kinds of robots. One of the things that I tell my team and my customers as well is, we have solutions that go into $200 toy robots. I don't know if you guys know that toy, Anki Cosmo, that was in, you can play in hands, $200 toy robot. We had a solution going in there, which is also used in wearable watches. It's an application processor with 7-core with GPU, comms as well. And we do have processors that go into industrial robots, like the industrial robot arms and others. So we have a whole slew of technology and building blocks that enable all kinds of robots. And one of the kicker here is, robotics is very close to a mobile device, I would say. Why? Because most of them, largely, most of them are battery operated. Most of them need a lot of intelligence. While cloud is an option, on-device compute and AI is paramount because decision-making, closed-loop control, latency, these are the issues where you need a lot of horsepower on the device to be a fully autonomous system. So we believe that the processors that we build for smartphones have the great lineage to lend themselves beautifully to applications such as robotics that need a lot of power or performance at very low thermal footprint and low power consumption. So that's what we pioneer in, and we are addressing that across all the segments, be it cleaning robots, be it warehouses, AMRs, and drones as well. So today, again, you guys have been talking about ROS2 and a lot of things have been going on. And I want to share some perspective of the global trends, which probably you guys are also aware of. So robotics is at very exciting times. And yes, for past decade or so, robots have been there. If you look at first robots in Japan, people made robots as hobby, right? And still, there is some of that in past decade as well. But what we are seeing is the technology is getting available and the price points are coming to a point where sensors, compute, AI, camera technology are in a very good form factor to address needs. Before, what used to be done with using a 21 board combination for a camera, for a comm, for a processor is now reduced to a credit card size board. So times are changing, and that is making robotics become mainstream. Robots are being now deployed in warehouses. I mean, everybody's familiar with the iRobot Roombas, which is one of the by far largest volume. Everybody has one kind of thing. And drones also have become very, very persuasive in terms of use cases. They started off as hobby photography things, but now we are seeing them being used for inspection to delivery and whatnot. So the market is adopting, the technology is ripe, the price points have gotten to a point where robotics can scale. And I believe at some point we would have custom chips made for robot. To be honest, today, we don't think we are there where there's a need or even a business justification to make a specific dedicated processor for robotics. But by far, the mobile phone processor with more souped up GPU, CPU is the best processor that fits robotics. And we are taking those to this market and lifting the tide of the market. A very healthy CAGR. People who look at the business side of things, they know that at the end of the day, when companies are making revenue out of these and having productivity, that's when adoption will take off. So we are excited about that piece. And why? Why is it happening? Yes, robots are getting affordable. Robots are becoming more intelligent, autonomous. That technology has arrived. But also there are a lot of trends, social demographic changes happening in countries like Japan and others. There's a lot of aging population, so adoption of robotics is becoming important for workforce, for labor, for things like efficiency. And then we know what happened during COVID, supply chain fragility. It's more about demand and supply of goods, not being able to keep critical components was a big pain point. But through automation, a lot of those can be streamlined. So people are implementing a lot of robotic processes after what they've experienced in this past 2-3 years of supply chain during COVID, what happened. And the thing that is, which I talked about, is the technology is getting much, much more relevant and useful, especially around generative AI. I'm sure you may not be missing a day without knowing what's new going on. And within what you know today is becoming irrelevant tomorrow, because the pace of innovation in generative AI field is really, really rapid. And one quick thing I'll talk about the generative AI part of things is, maybe I have a slide on that. When we talk about traditional AI, it was a great medium for machine-to-machine communication. But when it comes to generative AI, the friction that is between human and machine is being removed. And we'll cover that a little bit more. But the future of robot, like we said, is compute, security, and connectivity. Somebody mentioned earlier, ROS2 comes with great security. But what is great security on top of the software if the hardware root of trust does not support all of that? So what we believe in is the security is an end-to-end security where you can make the entire gadget. If you're not using the ROS part of things, you still have hypervisors running non-ROS part of things in a robot. Say an Android, and a robot could have 2 operating systems, Android for UX and UI, and Linux for real-time operation. And ROS runs on Linux and also on some of it on Android as well. But if the robot has vulnerabilities where ROS2 cannot take care of, I think it's still not foolproof. So having root of trust at hardware level security is paramount. And that is what I believe trust once broken is hard to win back, right? If there is one simple event somewhere that would happen and brings a bad rep for robotics, saying somebody hacked into it, and be in a home robot or in a factory robot, it would deter the growth. And we believe that keeping security in mind from the get-go is very important. And of course, compute. You guys know very well about compute. The more compute, any amount of compute is not good enough because you can come up with so many use cases. So compute is going to be generation by generation, going to have much more TOPS on AI, much more compute on CPU, GPU, because we are making more complex robots. But the kicker is going to be whatever you do, low power is important. It's easy to get an off-the-shelf product and run POCs, but when you think about commercialization of those things, if the experience around the charging, the downtime is not good, if the experience around security is not good, and seamless connectivity. We believe connectivity is robotics, fundamentals of robotics, all of you know, right? Sensing, thinking, acting, and communicating. These are the fundamentals of robotics, right? So comms is very important. And low power Bluetooth to 5G, and we'll talk about that as well. So these are the building blocks, in my opinion, and what we have been seeing people adopt as well. And as we talked or touched upon before, progression of AI is tremendous, and is being rapid. So now, keeping up with what happened yesterday, I was talking to somebody about large language models and now being able to make them master of specialists. There's a new model that got released where you're able to break down those. You don't need $132 billion parameter model for an entire. When you ask a question, it would be maybe regarding cricket, and you don't have to access all the 132 billion parameters. So they are talking about compartmentalizing that. So that will enhance how generative AI can be on device rather than being on cloud. So if you have on device generative AI, which we do, it changes the game as well, because cloud is not an option every time. When you talk about factories don't want their robots to be hacked and be connected to the cloud. So there's private network, there's local LLMs, there's on-device LLMs. So things are changing. And of course, AI, in my opinion, robot was the poster child of AI. I mean, AI is everywhere today, but 20, 30 years ago, if somebody said AI, first thing it would come to the mind is a robot. And again, we talked about this, so I'll try and skip some of that as well. But the essence here is generative AI builds that human-to-machine interaction to a very meaningful level than what traditional AI does. So that's the key thing here. 5G, again, 5G, robotics is going to be a big beneficiary. Maybe we don't see how things are going to get connected, but when you talk about lights out manufacturing, lights out warehouse fulfillment center, lights out this thing, this is all about private networks. And for the reasons I mentioned earlier, the Audi plant that's making cars, or the Tesla that's happening, is going to be implemented in 5G, private 5G labs, and private 5G infrastructures. And robots are going to be a big beneficiary of that, including things like robotic surgery would be beneficiary of private 5G. So the essence here is that private 5G is getting deployed. We see that Tesla implemented the private 5G network in their Croatian factories as well. We worked on that too. So these are all Qualcomm-based private 5G networks. And when you have 5G infrastructure, it's bound to be that the device need to have 5G as well. So 5G and AI together is going to be that killer combination. I'll skip this because this is all about ROS2, and you guys are better expert on that. But ROS2 is being lot of more improvements happening there, including security. We are excited about it. Most of our products support it, and the industry is adopting. And then there's ROS Industrial and a few other things as well. So good stuff. It's moving from the R&D to commercialization, and we see all of our customers use ROS in most of the robotics thing. So few things I would try to, again, bring together in the gist I had before is, yes, when you're making prototypes, when you're doing R&D research, things like use of heterogeneous compute, use of low power, more energy efficient devices, use of better form factor is not first thing that occurs in the mind. But what I would encourage is, yeah, R&D to commercialization is a big big step, and the things that need to be thought about early in development is leverage of heterogeneous compute. We believe that there's no silver bullet for any application. When you need real-time applications, you need to use CPU. When you need sequencing of tasks, when you need rendering plus image correction, you need GPU. When you need camera-based technology, you need a great ISP. And when AI is needed, and power-efficient AI, you need AI engines. GPU may not be the right choice in certain cases. GPU may be the right choice. But we believe in the philosophy of a heterogeneous compute platform. And if you look at any smartphone or any IoT SoC, it would have all these building blocks of CPU, GPU, DSP, AI engine, comms together, audio, video, all on one subsystem. That is what I think is the thought process, should be early in the process. Again, all the other stuff like reduced footprint, because you can make clunky devices, but if you want to fly it, you need to make sure it is on a drone and it can fly. So one of the projects that we worked on, which I'm really proud, because I built the robotics team in Qualcomm, our first flight platform is still today on Mars. So first unmanned flight on outside of planet Earth. First flight on planet Earth happened by Wright brothers. But Mars mission that happened in 2020 had the Mars helicopter that was powered by Qualcomm Snapdragon processor. So again, why we were the choice for that is because of the simple fact of form factor, efficiency in the performance versus thermal, and also because of the integration. So integration and footprint is going to be important in a lot of these use cases. I'll keep moving. And what we have done, especially working with a lot of researchers and also with the industry partners, we've understood the pain points for robotics developers. What in past has happened is the developers would have to make choices of finding the camera, finding the sensors, finding the IMUs and all. What we did was we collected all this feedback and we put together a robotics platform. We call it the RBX series, which has everything that we talked about earlier in terms of processing with CPU, GPU, camera and all. But more importantly, now we have vision mezzanines that need any kind of cameras. You have upward facing camera for SLAM application, you have depth cameras, you have main cameras for image quality. Then we have a sensor mezzanine, industrial mezzanine for industrial protocols like EtherCAT, Profinet, and flexible choice of deployment. And one of the things maybe you'll get a kicker out of this is UCSD San Diego, Professor Henrik Christensen has a master's course where RB5 is the platform that the students are starting to use as part of their projects. And again, the ROS offering is on top of the hardware we just talked about. It's no good that we give the best hardware modules, but we also build that thing on Ubuntu, Yocto, with ROS2 and the packages above that. So the great development platform, great for the community. I believe in this philosophy that rising tide lifts all boats, and we think as a robotics community, we have to work together to make sure the adoption of robotics happens. So we are doing our part for putting the best hardware out there with good choice of software and developer ecosystem. And then my closing side is this, right? I consider this is a broader IoT thing, but even robotics, it's not an individual sport, it's a team sport. I mean, it takes a village to get things done. It takes an ecosystem to get things done as well. So having great chipsets and solutions is one part of it. That's a great starting point, but having the software, the partners who can distribute these, we have Arrow here, eInfochip, there are partners who have this RB5 kits who distribute and make it accessible. We have, for example, system integrators. And one story around here is we work with Accenture, Deloitte, and others, but what happens is when a factory is deploying, they want to make a smart factory, they don't think about which processor should I use, which robot should I use, is not the first thing comes to their mind. They say, okay, let me talk to a system integrator, and they put things together. So now, not only that the ecosystem, people need to think about who creates the pull and who makes the decision at the point of implementation as well, and that's where system integrators. And all of this need to tie up with you being on the research side and the extreme end being the customer who's paying the money for it, and everything is in between. And we are trying to make this seamless progression of helping researchers, but also making the tide for robotics go up with an entire ecosystem. I know it was a rushed thing. I was told I had less time, so I rushed through a lot of stuff. But thank you so much for listening, and it was a pleasure to be here among you guys. Thank you.